Hi, everyone. My name is Deepsha Menghani, and I'm a data scientist at Microsoft. Today, I want to showcase this dashboard that I built for my stakeholders to show them the logic that I use to build my forecast sales and detect the anomalies. The idea was to give them this dashboard to play with the data themselves, change the filters, change the threshold, and see how that is impacting the forecasting and anomaly detection. I wanted them to be able to trust what we're building under the hood and bring them along the journey. So for this dashboard, as you can see, the product names are fake data, which I had a lot of fun coming up with those names because I primarily wanted to showcase the functionality of this application. This first page is the product sales data, where if you select a product and date filters, you'll be able to see the sales over time and some basic KPIs like total product sales or average weekly sales on the right side. If the user wanted to download that underlying data after they've added the filters, they can also copy or share that with someone. Now, the second tab is the forecast sales data, where if whatever data filters the user has selected, the forecast is recalculated on top of those filters for a monthly period. So let's say if you just wanted forecast from December 2019, and only that data would be used as the training data. Again, the user can copy and download the forecast the data for that certain filters that they have used. The anomaly detection tab is used to showcase how the threshold changes the anomalies that are getting detected. It uses an Anomalies package, which breaks down the time series into seasonality, trend, and noise, and then calculates the anomalies on that noise. So let's say if the user wanted to reduce the sensitivity, and they can just select that here and see, okay, now much less anomalies are getting detected. However, if they wanted even the slightest change in data to be noticed, they can increase that sensitivity. And now if you can see that even like we're catching much more slider shifts in the data set. Now, allowing the stakeholder to be able to play with this as well as try this out for different products and types of time series allowed us to come up with a time frame of how many data anomalies should we see in a row to be able to raise a flag for our upstream data sources. Now let's try that for another product. So there's this holes and more cardigan. And if I look at that time series, there are clear set of anomalies here where it's dropping. And let's see in the anomaly detection model how it's getting detected. So not only that drop is getting detected, but you can see because we had very high sensitivity from the past, a lot more anomalies are getting detected. The user can just reset to all the original settings, or they can select something that they want to try out how that would work for this type of a time series. Looking at forecasts, let's say, currently the forecast is calculated on all of this data that you see here for that monthly forecast. But let's say the user just wanted to look at data from or train the forecast on data from February 2020 onward. Let's try to select that and see what gets updated. So here the forecast is getting calculated just on that data after that dip that we saw in the time series. And the user is able to see, oh, how is that getting detected? How is that changing our forecast, etc. And download that table that they can share with their product teams. So this project was absolutely pivotal in allowing the stakeholders to understand both technical and non-technical how we're building anything under the hood, and for them to be able to trust the forecast and anomaly detection that we built. Thank you.